Hello everyone, in this video we're going to explore topic 7.8 exponential models with differential equations. Alright, first we're going to talk about the growth and decay function. In many applications, the rate of change of the variable y is directly proportional to the value of y. If y is a function of time t, the proportion can be written as follows: dy over dt equals k times y. Now, exponential growth and decay model theorem. If y is a differentiable function of t such that y greater than 0 and y prime equals k times y for some constant k, then y equals c times e raised to the k times t, where c is the initial value of y, k is the proportionality constant. Exponential growth occurs when k greater than 0. Exponential decay occurs when k less than 0. Now we're going to prove this formula, okay? So we're going to start from here. So I have dy over dt equals k times y, right? Now I need to separate variable, right? So I see y right here and y is right here. I need to divide both sides by y and multiply both sides by dt, right? So this guy turns out to be dy divided by y equals k dt. Now I'm going to take antiderivative both sides. Alright, so this guy turns out to be natural log of absolute value of y equals kt plus c, right? Now I need to exponentiate both sides, right? So I have e raised to this one equals e raised to this one, right? So this guy turns out to be absolute value of y equals e raised to the k times t times e raised to the c1, right? Now we look at this one, y always positive, right? So you can eliminate absolute value side, right? So it turns out to be y equals e raised to the k times t, right? Now this guy right here I can set as constant c, right? So it could be c right here. And is proved right here, right? Now let's take a look at the first example. The rate of change of y is proportional to y. When t equals 0, y equals 2, you have the first order pair 0, 2, right? When t equals 2, y equals 4, you have the second order pair 2, 4. What is the value of y when t equals 3, right? So t equals 3 and y equals how much? We don't know, right? We need to find, right? Now we're going to use the formula y equals c times e raised to the k times t, right? Now we're going to use the first order pair here, 0, 2, right? So t equals 0, y equals 2. We have 2 equals c times e raised to the 0, right? Then c equals 2, right? Because e raised to the 0 equals 1, right? So then you have equation y equals 2 e raised to the k times t, right? Alright, now we need to solve for k. We're going to use the second order pair right here, 2, 4, right? So I have 2, 4. Then I substitute into this equation right here, right? So I have 4 equals 2 times e raised to the 2k, right? So then e raised to the 2k equals 2. Take natural log both sides, so I have natural log of e raised to the 2k equals natural log of 2, right? Bring 2k to the front. And then you have natural log of e equals natural log of 2, right? But natural log of e equals 1, right? So divide both sides by 2, so k equals 1 half natural log of 2. Then the equation becomes y equals 2 times e raised to the 1 half natural log of 2 times t, right? Now finally, you're going to use this one to solve for y, right? So given t equal 3, substitute over here. So you have y equals 2 times e raised to the 1/2 natural log of 2 times 3, right? So it's going to be y equals 2 times e raised to the 3/2 natural log of 2, right? Now you can bring 3/2 back over here, right? So you have y equals 2 times e raised to the natural log of 2 raised to the 3/2. Now you know that e raised to the natural log of a equals a, right? So this guy turns out to be y equals 2 times 2 raised to the 3/2, right? So it's going to be 2 power of 5/2, right? Or y equals square root of 2 power 5, and it's going to be square root of 32, right? So it's going to be square root of 16 times 2, and it's going to be 4 root 2. This one is the final answer. Now let's move on to the next one, application of growth and decay. Half-lives. The half-lives of some common radioactive isotopes are as follows: uranium, carbon, strontium, plutonium, cesium, nobelium. Activity in Chernobyl, USSR. Example number 2. Suppose that 15 grams of the cesium isotope CS-137 that was released during 1986 Chernobyl nuclear accident and absorbed into the groundwater. How long will it take for the 15 grams to decay to 1 gram and become safer to drink? Now, you need to summarize the problem. 15 grams that was released during 1986, so it tells us that you have the first order pair. At t equals 0, you have 15 grams, right? 1986 is the initial time, which is t equals 0, right? Now, next one. How long will it take for 15 grams to decay 1 gram? Now, you know that this isotope is right here, right? Which means at 30 years, t equals 30, right? Then this guy right here, initial value right here becomes half, right? Half-lives, right? So it could be 7.5, right? Alright, now I need to use the order pair 0, 15 first. So I have the formula y equals c times e raised to the k times t, right? I need to solve for c first, so I substitute 0, 15 over here. So it will be 15 equals c times e to the 0, right? So c equals 15, right? So you have equation y equals 15 times e raised to the k times t, right? Now I need to use this order pair right here to solve for k, right? So I substitute this guy over here. Alright, so I have 7.5 equals 15 times e raised to the 30k, right? So then e raised to the 30k equals 1/2, right? Then I'm going to take natural log both sides, so I have natural log of e raised to the 30k equals natural log of 1/2, right? And then this guy becomes 30k equals natural log of 1/2, right? And k equals 1/30 times natural log of 1/2, right? So then you have equation y equals 15 times e raised to the 1/30 times natural log of 1/2 times t, right? Now finally, we need to answer the question right here. How long will it take for the 15 grams to decay to 1 gram, right? So which means you have the order pair t, comma 1, right? Substitute over here, so you need to solve for t, right? So have 1 equals 15 times e raised to the 1 over 30 natural log of 1/2 times t, right? I need to divide both sides by 15, so I have e raised to the 1 over 30 natural log of 1/2 times t equals 1 over 15, right? Now take natural log both sides, so I have 1 over 30 times natural log of 1/2 times t equals natural log of 1 over 15, right? Now I need to divide both sides by this guy. So it's going to be t equals natural log of 1 over 15 divided by 1 over 30 times natural log of 1/2. Then I'm going to hit the calculator, right? So you're going to add calculator. Then you hit enter. Now you need to convert this one to decimal. So you hit menu, number, convert to decimal. Hit enter. The answer is 117.207. Yes. Now let's move on to example number 3. An absent-minded graduate student at a university is studying a population of fruit flies in a biology lab. She works under the premise that this experimental population of fruit flies increases according to the law of exponential growth. She counts 100 flies after the second day of the experiment and 300 flies after the fourth day. However, she forgot to record the number of fruit flies she initially had at the beginning of the experiment. Approximately how many flies were in the original population route to the nearest fly? Alright, so first you need to summarize the problem. Alright, so she counts 100 flies after the second day, which is you have the order pair 2, 100, right? Next, she counts 300 flies after the 4th day, so you have the second order pair 4, 300, right? She forgot to record the number of fruit flies she initially had, right? Which means 0, y, right? Now we need to use the first two order pairs right here to solve for c and k, right? Since you don't have the initial value, now you have equation y equals c times e raised to the k times t, right? Use the first order pair, you have the first equation. This could be 100 equals e raised to the 2k, right? The second order pair, 300 equals c times e raised to the 4k, right? Now I need to divide this one vertically, right? So take the bottom, divide the top. It turns out to be e raised to the 4k divided by e raised to the 2k, right? C and C cancel out, and it's going to be 3. Now I need to use exponent rules, so this guy turns out to be e raised to the 2k, right? 4k subtract 2k equals 2k equals 3. I need to take natural log both sides, so then you have natural log of e raised to the 2k equals natural log of 3. So 2k equals natural log of 3. K equals 1/2 times natural log of 3, right? Now I need to substitute this guy back over here to solve for c. So I have 100 equals c times e raised to the 2 times k, but k for this one right here, times 1/2 natural log of 3. So 100 equals c times e raised to the natural of 3, right? Now, this guy turns out to be 100 equals C times 3, right? Because e raised to the natural of 3 equals 3. Now, C equals 100 divided by 3, right? So, the equation should be y equals 100 divided by 3 times e raised to the k equals 1/2 natural log 3, right? Times t, right? Alright, now you need to solve for y when t equals 0, right? Substitute over here, so you have y equals 100 over 3 times e raised to the 1/2 natural log of 3 times 0, right? So y equals 100 over 3, right? Now, if you want to convert this one to decimal, so it could be approximately 33.333 fruit flies. Now, you need to round to the nearest fly, so it's going to be 33. Now, let's move on to example number 4. 4 months after it stopped advertising, a manufacturing company noticed that its sales dropped from 100,000 units per month to 80,000 units per month. After the sales follow an exponential pattern of decline, what will they be to the nearest unit after another 2 months? Alright, so you need to summarize this problem. Alright, you have the first order pair, right? Initially, it's going to be 100,000, which is you have 0, 100,000, right? Now, 4 months later, so you have the second order pair, 4, 80,000, right? Lastly, what will they be to the nearest units after another 2 months? Which means t equals 6. You need to read the question carefully. Why, right? After another 2 months, right? So, now example 4 is slightly different from example number 3. Example number 4 is similar to example number 2, right? Because you have initial value right here. So you can solve for C directly. You don't have to use a system of equation like what you did in example number 3. So be careful, okay? So you have y equals C times e raised to the k times t, right? Substitute t and y, so it could be 100,000 equals C times e raised to the 0, right? So C equals 100,000. So you have equation y equals 100,000 times e raised to the k times t, right? Now you're going to use the second order pair right here to solve for k, right? So substitute over here. So you have 80,000 equals 100,000 times e raised to the 4 times k, right? Where t equal 4. Now you have e raised to the 4 times k equal 80,000 divided by 100,000, which is 4 over 5, right? Take natural log both sides, so you have natural log of e raised to the 4k equals natural log of 4 over 5, right? So you have 4k equals natural log of 4 over 5, right? So k equals 1 over 4 times natural log of 4 over 5, right? So the equation should be y equals 100,000 times e raised to the 1 over 4 natural log of 4 over 5 times t, right? Now, you're going to use this order pair to solve for y, right? So y equals 100,000 times e raised to the 1 over 4 natural log of 4 over 5 times 6, right? So right here I can write 6 over 4. Alright, now So y equals, I'm going to use the calculator to calculate this one, right? So it could be 100,000 times e raised to the 6 over 4, which is 3 over 2, right? Times natural log 4 over 5. Then you hit enter. Convert this one to decimal. So hit menu, number, convert to decimal, hit enter. The answer is 71,554, right? Because you need to round to the nearest unit, right? Now let's move on to the next one. Newton's law of cooling. Newton's law of cooling states that the rate of change in the temperatures of an object right here is proportional to the difference between the object's temperatures and the temperatures of the surrounding medium. It's going to be right here, right? Where T0 represents the temperatures of the object and T is represent the temperatures of the surrounding environment. Example number 5. The world famous pastry chef Bernie Rose removes a completely baked cake from an oven and places a cooling rack in a room whose temperature is kept at a constant 60 degrees Fahrenheit. Using a cooking thermometer, he determines the cake cools from 100 degrees Fahrenheit to 90 degrees Fahrenheit in 10 minutes. The icing that is to be used for the cake cannot be applied until the cake's temperature reaches 80 degrees Fahrenheit. How much longer must Bernie wait to ice the cake? Alright, so you need to summarize this problem. Alright, you have the first order pair. He determines the cake cools from 100 degrees Fahrenheit, which means at T equals 0 is going to be 100 degrees, right? The second order pair is going to be T for 10 minutes, it could be 90 degrees Fahrenheit, right? Now the question asks you to find at what time T the temperature reaches 80 degrees Fahrenheit, right? Alright, so you're going to use the formula right here, alright? So you have dt0 over dt equals k times t0 subtract te, right? Alright, but te right here is 60 right here, right? So you need to substitute 60 for te. Right, now you need to solve this differential equation by separation, right? So I'm going to separate this one first. So I have dt0 divide both sides by t0 minus 60, right? And multiply both sides by dt, so I have k dt, right? Now I need to take anti-derivative both sides, right? So this guy turns out to be natural log of absolute value of t0, which means t object subtract 60 equals kt plus c, right? Now I need to use the order pair right here to solve for c, right? So t equals 0, this guy becomes 0, right? And 100 right here, which is t object, right? So I have natural log of absolute value of 100 subtract 60 equals c. So this could be natural log of 40 equals c, right? I have natural log of t0 minus 60 equals k times t plus natural log of 40, right? Now I need to use the second order pair, which is 10, 90 right here to solve for k, right? So at t equal 10, t0 equal 90, right? So I have natural log of absolute value of 90 subtract 60 equals 10k plus natural log of 40, right? So it could be natural log of 30, right? Subtract natural log of 40 equals 10k, right? So k equals natural log of 30 subtract 40, which means 30 divided by 40 is going to be 3 over 4, right? Divided by 10. Then the equation becomes natural log of t0 minus 60 equals k. I can rewrite this one as 1 over 10 natural log of 3 over 4, right? Times t plus natural log of 40, right? Now we're going to use the third order pair right here to solve for t, right? Natural log of t0 equals 80. So 80 subtract 60 is going to be 20 equals 1 over 10 natural log of 3 over 4 times t plus natural log of 40, right? Subtract natural log of 40 both sides, so you have 1 over 10 times natural log 3 over 4 times t equals natural log 20 subtract natural log 40 is going to be natural log of 20 divided by 40. So it could be natural log 1/2, right? So then t equals natural log 1/2 divided by 1 over 10 times natural log 3 over 4, right? So then this guy turns out to be 10 times natural log 1/2 divided by natural log 3 over 4, right? Now I'm going to print up the calculator. So I'm going to hit 10 times parenthesis natural log 1/2, which means natural log of 0.5, right? Divided by natural log 3 4, which means natural log of 0.75, right? Then I hit enter. The answer is 24.094, right? Now let's move on to example number 6. Fish are being introduced into a man-made lake. The change in the rate of fish f with respect to time t is directly proportional to 900 minus f, where t is measured in years. When t equals 0, there are 400 fish in the lake, and 3 years later, there are 600 fish in the lake. Alright, now we need to summarize the problem. The change in the rate of fish f, which means df, with respect to time t, which means over dt, right, is directly proportional, which means equals k times 900 minus s, right? I where t is measured in years. When t equals 0, there are 400 fish. You have the order pair 0, 400, right? 3 years later, which means at t equals 3 is going to be 600, right? So you already summarize the problem. Now write and solve the differential equation that describe this situation, right? So we have df over dt equals k times 900 minus f, right? Now you need to separate the variable first, right? So it's going to be df divided both sides by 900 minus f, and then multiply both sides by dt is going to be k dt, right? Then you're going to take antiderivative both sides, so it could be like this, right? Now we need to solve this one. Remember, if you have antiderivative of ds over s minus a, it's going to be natural log of absolute value of s minus a plus c, right? But this one is a minus f. F is the variable. Look at this guy, right? This guy, this guy. Alright, so it's going to be opposite, right? So it turns out to be antiderivative of ds over a minus s is going to be minus natural log of absolute value of a minus s plus c. Alright, so keep that in mind. So this guy turns out to be negative of natural log of absolute value of 900 minus f equals k times t plus c, right? Now we need to use the first order pair right here to solve for c, right? So we have negative natural log of 900 subtract 400 equals t equals 0, so this one equals 0, so it could be c, right? So c equals negative natural log of 500, right? So then I have the equation negative natural log of absolute value of 900 minus f equals kt minus natural log of 500. Alright, substitute into this equation right here. I get this one, right? Now I need to use the second order pair right here to solve for k, right? So I'm going to substitute over here. I have negative natural log of absolute value of 900 subtract 600 is going to be 300 equals t equal 3. So I have 3k minus natural log of 500. Now I'm going to add natural log of 500 both sides, right? So I have 3k equals natural log of 500 minus natural log of 300, right? So 3k equals natural log of 500 divided by 300 is going to be 5 over 3. So k equals 1/3 natural log of 5 over 3, right? So then I substitute this guy right here back to the equation right here. So I have negative natural log of absolute value of 900 minus f equals 1/3 natural log of 5 over 3. Now be careful, t is right here multiplied by natural log of 5 over 3. It's not 5 times t, so be careful, right? So you need to bring t to the front, right? So I can write this one as t over 3. And then I need to erase this one, right? To get rid of the mistake, right? Now I want to get rid of the negative side over here, so I need to multiply both sides by -1. So it turns out to be natural log of absolute value of 900 minus f equals natural log of 500 subtract t over 3 natural log of 5 over 3, right? Now I can bring t back over here, right? So this guy turns out to be natural log of absolute value of 900 minus f equals natural log of 500 minus natural log of 5 over 3 raised to the t over 3, right? Now it turns out to be natural log of absolute value of 900 minus f equals natural log of 500 divided by 5 over 3 raised to the t over 3, right? Now both sides have the same natural log, right? You can equate this guy and this guy, right? So it could be 900 minus f inside the absolute value side equals 500. I need to bring this one to the top, so then I need to change the sign of the power. So it could be times 5 over 3 raised to the negative t over 3, right? Now observe that the number of fish is getting smaller and smaller as time increases, right? So then this guy always positive, right? So this guy turns out to be 900 minus f without the absolute value sign, right? It's gonna be 500 times 5 over 3 raised to the negative t over 3, right? So then the equation becomes f equals 900 minus 500 times 5 over 3 raised to the negative t over 3. This one is the final answer for question A, right here, right? Now question B, find the fish population in another 3 years, which is t in this situation is 6, and then f is unknown, so keep that in mind. Substitute 6 for t into this equation right here. You have f equals 900 minus 500 times 5 over 3 raised to the negative 6 over 3, which means negative 2, right? You can hit the calculator. It's gonna be 900 subtract 500 times parenthesis 5 over 3 close parenthesis raised to the negative 2. Hit enter. The answer is 720. Now let's move on to question C. Find the limit of f of t when t approaches infinity and explain what the answer means. Alright, so we have limit f of t is right here. Now we can convert this one to positive exponent by rewriting this one as limit of 900 500 multiplied by, you just flip the fraction right here, 3 over 5, and then this guy becomes positive exponent t over 3. Alright, remember if you have a over b power up negative s, this guy becomes b over a power up s, so keep that in mind. T approaches positive infinitive. This guy right here approaches 0 because the numerator is less than the denominator, right? So it's gonna be 900, right? Because 0 times this one equals 0. Now you need to say that the maximum number of fish that could inhabit the lake would be 900. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.